So we talked about if you have something in exponential form, like 4 to the x equals 20, then in order for us to solve it, we can change it to logarithmic form. So that means put a log, start with the 4, go to the 20, and back to the x so that we can solve it. Because it's not always things that we know, like 4 to the x equals 16, or we know that that's 2. So whenever you have something to a power, in order to solve it, we're going to rewrite it like we did on these first ones. So let's look at number 8. I still want to rewrite it at some point, but I can't rewrite it yet because there's something in the way. So I need to do something else first. Any ideas? Subtract 5. So let's get that 16 to the x minus 7 by itself. Alright, when I subtract 5, I do get 16. Now, there's a couple ways that you can solve this. We can do it the same way we just did, that we just talked about, and rewrite it in log form. Okay, let's do that first. So we would have log, always start with your base, go around to the answer, equals the power. Log base 16 of 16 equals x minus 7. Now, you probably already know what log base 16 of 16 is. 16 to what power is 16? 1. If you don't know, just a reminder, you can go to alpha and window, number 5, put your base in there, except you got to type it right, 16, sorry, and then 16, so that you can do that if you need to, if you want to do it on the calculator or Desmos, either way. Okay? We know that that's 1. So that tells me 1 equals x minus 7. So how do I solve for x now? Add 7, so x is 8. I will tell you on that one, because you had the same base on both sides, we could have said x minus 7 equals 1 and not have to rewrite it. And just know that the powers are going to be equal. But if you didn't get that, that's okay. Alright, let's look at number 9. Again, we want to get the power, or the number to the power by itself first. So I want to get this part 6 to the 4x all by itself. So what can I do with that 2? I don't want to minus it because it's being multiplied, so I want to divide both sides by the 2. You're not going to combine the 2 and the 6 because the 6 is raised to a power, so you can't multiply the 2 and 6 together. Good so far? Alright. At that point, I'm going to now rewrite it in log form. Once you have a number to a power equals a number, you can rewrite it in log form. So we're going to say log. What's our base going to be? 6. Go to the 5 on the other side of the equals 4x. Alright, after that, that's where we figure out what log base 6 of 5 is, and then worry about that 4x. So alpha, window, log base. Okay, we said it was log base 6 of 5. 898. And then what do we want to do on both sides? Divide by 4. So whatever that was, divided by 4.22. Questions about that one? Alright, the next one we want to do is this one that has an E in it. You can do it the same way. We can rewrite it in log form and then go from there. I will tell you, because it's an E, you actually could rewrite it in what's called natural log form. Since I know that the ln has a base of E, that's one way to rewrite it. It really doesn't matter either way. Both of it will give you the answer. What I'm meaning, though, is that instead of writing a log, I can say natural log. What would be the base? E. Remember, always start with the number being raised to power. And then E, and then it goes to the 2 and equals x. See, natural log E of 2, natural log base E, that is what natural log is. I don't even have to type the E if I do that one in the calculator. I just press natural log, which is over here but underneath the log, and then I just press 2. Now, very quickly I want to show you if instead you would have used a log, you could do log of E and plug in an E right there, and then 2. Look, you get the same answer. So it doesn't matter whether you use the natural log or whether you use log base E. You're still going to get the same answer. Okay? So that gives you 0.693 equals x. Okay, so on the first one, there's nothing extra. It's just a number to a power equals a number. So if I was doing the log, I would do log base 2 of 60 equals 3x. And then I could figure out what log base 2 of 60 was. And then what do I do to finish the problem? Divide by 3. So I'm going to go to alpha and window, number 5, log base 2 of 60, and then I'm going to divide that by 3, so I get 1.97. Questions about number 1? Number 2. First step on number 2, in order to solve that one, I'm going to have to add 10 on both sides, because I want to get that part by itself. So I add 10 on both sides. 5 to the x equals 110. And now I'm at a log problem because I have a number to a power equals an answer. So log base 5 of 110, always go to the other side, equals x. And so whatever I get in the calculator will be my answer on that one. Alpha window. Yeah, you got to go ahead and find out what that equals, since we can plug that in the calculator. So x is 2.92. Alright, and then number 3. Again, we have a number to the power equals 200, so I would want to start with just rewriting it. I am going to have to do something with that in just a minute, but we'll figure it out. Let's go ahead and do log base 15 of 200. Log base 15 of 200, 1.96. But then to solve it, I'm going to add 2 on both sides. So I'm going to add 2 to that, and I get 3.96. Right. So that's the kind of equations that just have numbers to powers. Alrighty. So what if it's not numbers to powers? What if it's like number 11 or 12 where there's a log there instead of a number to a power? Well, we're going to do this the opposite way. Instead of changing it to a log, we're going to get rid of the log to solve it, because I need to get this x by itself in order to solve it. Okay? So, we're going to rewrite that one. And we're going to say 36 to the 3 over 2 equals x. So, 36 to the 3 over 2 equals x. You might could figure out what 36 to the 3 over 2 is without doing anything. You could also just plug that in the calculator. 36 to the 3 over 2. We get 216. So x is 216. I'm trying to get number 12. I'm trying to get that x by itself. So I want to rewrite it. Start with a 3. So what power is 3 going to be raised to? To the second equals 4x. So first thing I'm going to do is I'm going to figure out what 3 squared is. It's 9. And then what do? To find x, divide by 4, and I get 2.25. So basically, you either write it in log form or exponential form, and then you do it the other way and solve it. Let's look at number 13. This one looks different. What looks different about number 13? I don't see a power. I don't see a base. But it's an ln, and so what's the understood base? E. So I know there's an e down there, even though I don't see it. So if I'm going to rewrite it in exponential form, I'm going to start with that e and rewrite it. So e to the second equals x minus 1. Alright, e to the second is in the calculator. You do the second divided by and then square it. There's e to the second, 7.39. And then what do I do to solve for x? Add 1. Alright, number 14. Go ahead and rewrite it. You might not know how to solve it, but go ahead and rewrite it first. Alright, so if I rewrite this one, what am I going to start with? 8. And what power am I going to raise 8 to? 2/3. Equals x squared minus 5. Okay, that looks weird, but let's go ahead and figure out what 8 to the 2/3 is. It comes out to be 4. Okay, I'm trying to get x by itself. So now what? Add 5. And I want to figure out what power, when I raise it to the second power equals 9. Or I just take the square root on both sides to get x by itself. And actually you get plus or minus 3. Anytime that you take the square root on both sides, you get a positive of that number and a negative of that number. Now, the reason I can go ahead and do that is because I just have the x squared and a number. If the problem had been like x squared there and then an x here, I would have to factor it or do something different. I couldn't just take the square root on both sides. Okay?
So are we putting the plus and the minus because we don't know?
Alright, 15 through 18 are a little bit different because they've got more than one log or more than one natural log there. You see on up through 14 how it was just one log that was there? But look, there's 2 logs on 15. If there's a log on both sides, and it's just log of something equals log of something, as long as the bases are the same, what you can do is you could say the insides of the log equal each other. We can just get rid of the logs, or the natural logs, and we can say, oh, well that means x squared plus 3 equals 4, and we can just solve it. So we would subtract 3 on both sides, and then solve it the same way we just did. X squared equals 9, so what would we do? Square root, and so what do we get for our answer? Plus or minus 1. Number 16 is very, very similar. Notice it says log of something equals log of something. Because they're the same and it's just one log, I can go ahead and say that these 2 parts equal each other. So I get x minus 5 equals 2x minus 8. And then we're just going to solve it. We're going to subtract x on both sides. That way I can just get a positive. Add 8 on both sides. And we get 3. Now, I will tell you that in this particular problem, 3 is actually not going to work. And you won't see it very often, but if I plugged 3 back into the equation, 3 minus 5 is negative 2, and you can't ever take log of a negative number. So probably in this problem there would have been absolute values here, which doesn't really change how you solve it. It just makes it so that that answer will work. Okay, that's just a weird problem. Most likely there would have been absolute values there. Number 17. Similar kind of question again. We have log of something equals log of something. And we can just say that the two things are equal. Because I have x squared and because I have x, I can't just get the x's together and get the numbers together because I got a little bit of both. I need to get everything on one side. Okay? So I'm going to subtract 3x and I'm going to add 10. And I get x squared minus 7x plus 10 equals 0. Any questions about that? What I did is I moved the 3x over, I subtracted it, and I added 10. Now, to solve that, what you're going to have to do is you're going to have to factor it. You're going to have to find the things that multiply to give me 10, that add to give me 7. That would be 5 and 2. Both of them will be negative to make that negative 7. After you get those two answers, you set it equal to 0 and solve. So what would our answers be? X equals 5 and 2. Now, when you start with a log, especially when you have log on both sides, you really should check your answers because they may or may not work. Here's what you do. You take one of the numbers, like 5, and you plug it in right here. Make sure you get a positive number. You take the 5 here, make sure you get the same positive number. We do. Then you take 2. You plug the 2 in. Make sure you get a positive number. Same thing here. Do you get a positive number when you plug in 2? See, 3 times 2 is 6. 6 minus 10 is negative 4. If you get a negative number when you're taking the log of it, it doesn't work. So 5 is the only solution. The only time that you have to check your answers like that is when you have logs on both sides. Okay. Try number 18. So on 18, because they both have log on both sides, I'm just going to set their parts equal. 3x plus 8 equals x squared plus x. I'm going to move everything to the right side to get the x squared by itself, or to get everything with the x squared. So I'm going to subtract 3x and subtract 8. When I subtract 3x, that's negative 2x. Subtracting 8 is a minus 8. Then I find the things that multiply to give me 8, that give me 2. So that would be a negative 4 and a positive 2. And then if I solve, I get 4 and negative 2. Okay, again, you want to take those numbers and plug them in and make sure you get positives. If I plug in the 4, that's 12 plus 8, which is 20, good. 4 squared plus 4, we're good. Let's try the negative 2. 6 times negative 2, 3 times negative 2 is negative 6, plus 8 is 2, that's good. Negative 2 here, squared is 4, minus 2 is 2, that one's good. That is a case where both of the answers work. Just because the answer was negative didn't mean it was not correct, as long as it works in both equations. So to finish the kinds of equations that we're going to talk about, the only other kind of equation is equations kind of like number 19 and 20. Notice that there's lots of logs, or natural logs, and they're not set equal to each other, so you can't just say, oh, whatever you're taking of is going to equal each other. In this case, in both of these cases, This is where you're going to use your log properties. The reason that we've been talking about those log properties is so that we can solve problems like this. Okay? So what do I know about two logs or natural logs when there's plus between them? What can I do? Multiply. So I can make this natural log of x times x plus 2 and equal it to natural log of x plus 6. That's using a log property because I put those two natural logs together. Now, by doing that, I have a natural log of something equals natural log of something else. And that's kind of nice because now I can just say that these two things are equal to each other. I am going to go ahead and multiply x by both things. So x squared plus 2x equals 6. And I can do that because it's natural log of each. Works out. Then I'm going to subtract. This is an interesting one because that doesn't factor. Yep, this over here is supposed to be x plus 6. I just wrote 6. I don't know why. So there's really an x plus 6 there. You do subtract the 6, and we should subtract that x. When we subtract that x, we do just get a 1x. Sorry about that. And actually that makes the problem a little nicer because now it does factor. 2 times 3 does give me 1. So that would be x plus 3, x minus 2. When you work that out, that's going to give me x equals negative 3 and x equals positive 2. I think positive 2 is going to work in my equation. Negative 3 is not going to, and the reason is because when I plug the negative 3 right here, I would have natural log of a negative, which is not a good thing, and so that can't happen. So that's a case where we use the log properties to put it together. 20 is a similar kind of question. We still want to use those log properties to put it together. So how can I put that together? It's got a minus between it. Let's make it a divide. So log 2 base 2 x plus 5 over x minus 2. It may look a little bit more complicated. I don't have logs on both sides, so I can't just say something equals something. I only have one log, but this is that first kind of problem where I'm going to rewrite it in exponential form. So I'm going to do 2 to the third equals whatever we're taking it of. Now to solve that, this is a cross multiplying kind of problem. You can think of it as that over that. That 2 to the third is 8. And so when I start to cross multiply, and I can do 8 times those, that's 8x minus 16. And then cross multiply this side, so that's x plus 5. Get your x's together. Add your 16. And then divide by 7. And quick glance, 3 minus 2 is 1, 3 plus 5 is good. So we didn't get a negative, so x equals 3 should be okay.